Welcome to Exercise 4, Quantitative Approaches to Interpretation Using the Boston Fingerprints Project dataset. So as you've already discovered in Exercise 3, the use of morphometric parameters as scalar fields has a great deal of potential in analyzing the dataset. So in this exercise, you will learn to use CloudCompare to calculate morphometric parameters and visualize these as scalar fields, work with multiple meshes at the same time by assigning individual meshes to different viewports, and incorporate quantitative approaches into an interpretation of the lifeways of pH 25. In exercise 2, we explored the potsherd pH 25 using MeshLab and used visual inspection and simple measurements to hypothesize how the fingerprints were applied to the potsherd and whether these were all a part of the same event when they were applied. So let's hypothesize that not all of these fingerprints were applied at the same manufacturing stage. Some might have been applied when the clay was still wet and hadn't had time to dry yet. This might have made the clay more malleable, and so the fingerprints may have made more of an impression, or if it was a bit stickier, more clay may have come away with the potter's finger as a result. We could also then hypothesize that fingerprints made at this pre-drying stage would have resulted in rougher fingerprints than those made after the pot had dried. So to test this, we could compare the average roughness of each individual fingerprint in CloudCompare. So first, do as I've done here, where you import the STL file for pH 25, the merged version, into CloudCompare. And now we're going to use the segmenting tool to isolate the fingerprints you identified in exercise 2 into separate meshes. So as you're segmenting these individual fingerprints out, be sure to rename these parts in a memorable way. So in the following steps, they've been labeled accordingly as MO, M1, M2, M3, and M7 as they were in exercise 2. So you can do it that way. You can do something a bit more intuitive for yourself if you like, but just make sure that they are a bit more identifiable rather than just mesh.part. And as you're segmenting each of these out, it's easiest just to go from the remaining mesh from before. Otherwise, you'll end up with all sorts of duplicates and very large file sizes. So just stick with segmenting from the same mesh.remaining for now. So hopefully you've clipped these fingerprints as close to the edge of the identifiable fingerprint as possible, because the way the software works, these analyses will be affected by any extra mesh that you've included. So this should be roughly what you have. You can delete the remaining potsherd if you like. If you want to look at each of these individually, you're able to allocate them to different 3D spaces, and so you can do this with the 3D views drop-down menu. First, so you create a new one. You see there's nothing in here. And then you navigate to one of your meshes, and you go down here in the properties to current display, and you can switch this to 3D view 2. And so now, well, maybe I want that actually on 3D view 1. And this one will go to 3D view 2. And so you just continue doing that 5 times. And then you can allocate each of the fingerprints to a separate 3D view. Great. So after you've got each of the individual fingerprints isolated on different 3D views, we want to make sure that these meshes are uniformly flat, as we did in exercise 3. I tend to use the fit to plane option under edit, just so that the software identifies what is considered level for these fingerprints, but you can use either method. So you should have aligned each of the meshes and exported their aligned Z coordinates using the export coordinates to SF option for each of the fingerprints. As briefly explained at the start of exercise 3, some of the functions of CloudCompare work with the vertices of the mesh as a point cloud rather than working with the mesh itself. This is the case for calculating roughness, surface variation, and other morphometric parameters that you'll see here. These individual points are the only real data anyway, as they are the points that were measured during data capture, no matter which kind of data capture it was. The mesh is actually a rough approximation of the object surface based on the density of your point cloud. So making these calculations off of the point cloud is technically more accurate anyway. So to calculate roughness and surface variation for these fingerprints, ensure the vertices component under your mesh is selected and enabled in the DB tree. Then you navigate to Tools and select Other, and then Compute Geometric Features. So for this one, we'll select roughness and what else? Whatever else you like to calculate, but for now, at least roughness and surface variation. So in the local neighborhood radius box, the software will have provided a suggested kernel radius, but it's usually far too small to be useful. So you can try playing with the setting to see the different results, but one that has been relatively reliable for this data set is 1.1184. And so we'll need to make sure that this is set for each of the fingerprints so that they are working with the same radius. Okay, and so here under scalar fields, there are 3 scalar fields available, and you can see that there's our Z coordinates from before, there's the roughness and the surface variation. So you can select between each of these, and they should change a bit either way. So select roughness for now, and make sure that you have the color scale. So under here, you can add the color scale and make it visible off to the side so that you can check the values that have been calculated for each of these points. So now you just need to repeat this step for each of the fingerprints in your dataset. Okay, once you've done that, you can now alternate between the 3D viewports to observe the differences in roughness between the fingerprints. So take a note of the numbers at the extreme ends of the color scale on the right. So which fingerprints have been calculated to have the roughest relative surface? So we've got 0.08 here. We've got 0.21 here, so a bit more rough for this one. This third fingerprint is 0.179. 0.23 for this fingerprint, and 0.096 for this fingerprint. So now have a look through the surface variation for each by changing the scalar fields for each of them. Make sure you have the correct one selected when you go. And then just observe how much the surface variation changes between each of the fingerprints. Does this have different results from your ranking of the fingerprints by roughness? If we look at roughness only, which I have here on viewport 3, it's clear that this fingerprint is less rough than the others. The color scale only goes up to about 0.09. In the handout, it went up to 0.089. Again, this depends on how you've snipped your fingerprints. The other fingerprints overall tend to run between 0.179 and into the 0.21, except for fingerprint M0. So it could be that these fingerprints actually were made on a different occasion after the pot had dried, but before it was fired. This difference is less apparent if we look at surface variation, but it's clear that fingerprints M1 and M3 are characterized by more surface variation than the other 3. So if we inspect M1 and M3 in particular, we might notice that you can change it to roughness to kind of highlight this a bit better, that if we look at this visually, there are distinct peaks in the surface that are missing from the other fingerprints, and this wouldn't be characteristic of fingerprints in general. So this patterning is suggestive that the clay was wet when the fingerprint was made, so much so that the clay pulled away when the finger was removed from the surface, and this pooling occurred. So if you want to do a bit of experimental archaeology, if you have some clay around, you can try making fingerprints in the clay at different levels of dampness. If you have paint available as well, you can make a fingerprint on a piece of paper and try using different levels of or different amounts of paint. And you might be able to see this difference. It's particularly visible in this fingerprint here. Actually, this where it's kind of pulled away and pooled a bit. So it might end up looking a bit like PH25's fingerprint M1 or M3. So at what step of the pottery manufacturing process might the potter have picked up a damp pot? Could it have been moved twice? Can you think of 2 instances when a pot might have to be moved during the manufacturing process? Maybe it was taken away from the pottery wheel to a shelf to dry, and then maybe after moving it from the shelf, they had to move it back into the kiln. So it's just thinking about these processes. That's quite useful. So make sure you take a snapshot of your fingerprints. If you want to do this a bit easier, you can, under 3D views, you can set it to tile, and then each of your fingerprints should be visible. So take a snapshot either of all of them with roughness applied, or all of them with surface variation, and discuss your interpretation and what differences you observed in your data sets. Is it the same or different as what we've highlighted in the handout? And then add this snapshot to your gallery and add your explanation as a caption.